Okay, and we're recording. I'm going to go ahead and try to record on Zoom as well. All right. Yes. Yeah, it's okay. All right. So for this first one, we are asking 60 South Koreans about their satisfaction with democracy in South Korea. I want to know the probability that 25 or more people would not be satisfied with how democracy is working. Okay. So I'm going to go down to South Korea, which is here. And we've got 35% which are not satisfied and 64% that are satisfied with their democracy. So if I want the probability that 25 or more people would not be satisfied, my probability of not being satisfied is 35%. In South Korea. Is this a binomial or a geometric? Let's go Kyle. Okay, it's binomial, you're right. How do you know that this is a binomial? Okay, we know it's a binomial because there's a number of successes that we're looking for. We're not just looking for the first success. Okay. I'm going to jump down to Eric. Eric, is this a PDF or a CDF? Okay, CDF, you're right. How do you know this is a CDF? Okay, so it's CDF because it's a range. I'm not looking for 1 point. Perfect. Okay, then I need an N, a P, and an X. So that's the number of people total that we are asking, the probability of success, and then how many we want to count up to. So next is Jin. Jin, what is my N? Number of people. Okay, and now can you take it? So what's my N? $60, perfect. Abby, what is P? .35 is decimal. Okay, and then Andrew. CDFs can only count up. I want 25 or more. So do I need a 1 minus or do I not need 1 minus? I need a 1 minus. Okay, 1 minus, and then I think we're back to Kyle. Kyle, what should go here? If I take away 25, 25 will not be included. 24, there we go. So I do not want from 0 to 24 people to not be satisfied out of 60. And that means I do want 25 or more people to not be satisfied. Okay, any questions on number 1? Okay, number 2. We're asking 37 Japanese people about their satisfaction with democracy in Japan. The probability that less than 20 would not be satisfied. Okay, so here's Japan. 56% of people in Japan were not satisfied with their democracy. So 56% not satisfied. I want the probability that less than 20 would not be satisfied. Next is Eric, I believe. Eric, is this binomial or geometric? Eric, would this be a binomial or would this be a geometric? Okay, it is a binomial. It's a binomial because I'm looking for a number of successes. I'm not looking for the first success. Next, I've got two gins. Okay, Jin, are you here yet? Okay, is this a PDF or a CDF? Okay, this is a CDF, you're right. CDF because we're looking for a range, not looking for a point. Less than 20 could be 0 or it could be 20. Abby, what's our N? Abby, what should go here? Okay, 37. Then our P we said was 56%. So that's 0.56 as decimal. I want less than 20. So Niall, do I need a 1 minus or do I not need a 1 minus? Okay, we do not need the 1 minus. And Andrew, what should go here? Yep. 19, perfect, because we want less than 20. All right, any questions on 1 or 2? Okay. Third one, the probability that the first person who would be satisfied with democracy would be on or before the 5th person asked for South Korea. 64% are satisfied in South Korea with their democracy. Kyle, is this a binomial or a geometric? Okay, this is geometric. How do you know? Okay, we don't know the sample size, and we're looking for the first success. Okay, Niall, is this a PDF or a CDF? I think I've lost audio from everyone who's in the classroom, maybe. So if you can type in the chat, I can see your chat. Is this a PDF or a CDF? Sure. I've got 2 Niles. All right. I'm gonna mute everybody in class, and we'll unmute people as we call. We'll see if that helps. Okay. So Nile, is this a PDF or a CDF? Okay, this is a CDF. Because I want on or before the 5th person, so we're not looking for a point, I'm still looking for a range. Okay, we said our probability is 0.64. I want on or before the 5th person. So Abby, do I need a 1 minus or do I not need a 1 minus? Okay, I do not need a 1 minus. Perfect. And Jin, what number should go here? Okay, I think you're talking about the probability maybe. So I've got the 0.64 already. We're on number 3. So I want the last number here for number 3. If I want this geometric to be on or before the 5th person, then if I put a 4 here, that would be 0, 1, 2, 3, or 4. But if I'm on or before the 5th person, then 5 is okay. So this should be 5. Okay. Any questions on 1, 2, or 3? Okay, last one. We're asking our Japanese people about their satisfaction with democracy again. I want the probability that the first person who would not be satisfied with how democracy is working would be after the 3rd person asked. So in Japan, we have 56% are not satisfied with the way their democracy is working. Andrew, is this a binomial or a geometric? Okay, this is geometric, so I'm looking for the first person who is not satisfied. Kyle, is this a PDF or a CDF? Okay, CDF, I'm looking for a range after the 3rd person. So that means if it's after the 3rd person, it could be person 4, 5, 6, 7, or 8, all the way up. So that is a range. I've got our p-value, we said was 0.56. Okay, I want after the 3rd person. So Niall, do I need a 1 minus or do I not need a 1 minus? Okay, do we need a 1 minus or do we not need a 1 minus? I do need, okay. I do need the 1 because we are after the 3rd person. Okay, and then Eric, what number should go here? So if I put a 4 here, I will take away the 4 as well. I want after 3, so 4 should be okay. So this one should be 3. I do not want 1, 2, or 3 people to say that they are not satisfied. I want 4, 5, or 6, or 7, or 8. So I want after 3. Okay, I'm going to go open this up to any suggestions for topics that you want to go over. Does anyone have another topic besides probability that they want to talk about? Let me stop last time. I don't remember. So what was the topic? So be whatever we stopped at last class is all I heard. So last class we had the oral exam that we did or whatever. So we had linear regression, we had some derivatives, we had some unit circle values. Yes, I can hear you. Oh. Sorry, you're cutting in and out. I'm gonna have you type instead, because I can hear about half your words. Sorry, Abby. Okay, this one, linear regression. Abby, do you want linear regression? Okay, I still can't hear you, so I'm gonna mute you. I can hear other people who are in your classroom. If you can jump over to someone else's mic. So I'm gonna unmute Jin really quick. Okay, what topic are you guys looking for? Third page? Okay. Oh, okay. Sorry. Okay, third page, this is derivatives. All right, so we'll do some derivatives. Okay, I've got several functions here. I want you to tell me what the derivative is and then what happens when we plug in the point. So let's start with Nikita. Nikita, if I derive tangent, what happens? Not secant tangent, that's what happens if I derive secant. Okay, this will be secant squared. Okay, then I'm going to plug in 3 pi fourths. So my derivative at 3 pi over 4 will be what happens if I plug in 3 pi over 4 into secant squared. Okay, at 3 pi over 4, we are here, where our side lengths are equal. So my cosine is root 2 over 2. My secant will be the flip of that. So this will be 1 over root 2 over 2 is 2 over root 2, and I am squaring it. So if I square that, that'll be 2 squared is 4, divided by the square root of 2 squared is 2, is 2. Okay, over to Eric. If I derive 4 sine x, what will I get? for cosine x, okay. If I plug in 5 pi 6, I'll have 4 times the cosine at 5 pi 6. The cosine at 5 pi 6 is negative root 3 over 2. So this would be 4 times negative root 3 over 2. My 4 and my negative 2 will cancel. So this is negative 2 root 3. Okay, I'm going to go gin next. Gin, if I derive secant, what will I get? Secant tangent. Okay, I'm going to plug in pi 6. So at pi 6, my cosine is root 3 over 2. That means my secant will be 2 over root 3. My tangent is y over x, so that's 1/2 over root 3 over 2 is 1 over root 3. And if I multiply straight across, that gives me 2 over 3. Okay. So next I've got I'll go Andrew next. Andrew, what's going to happen if I derive this? Okay, so that was product rule. I had f and g. So if I derive, I'll get f prime g plus f g prime. Then I'm going to plug in our value. F prime x is pi thirds. Okay, so if x is pi thirds, f prime x is going to be negative cosecant of 2 pi thirds times the cotangent of 2 pi thirds times 2 times the cotangent of pi thirds plus the cosecant at 2 pi thirds times negative cosecant of pi thirds. Okay, so at 2 pi thirds, my sine is root 3 over 2, so my cosecant is the flip of that, is 2 over root 3. So I've got negative 2 over square root 3. My cotangent would be x over y, so that's 1 over root 3. It would be negative, because my x is negative, times 2. Cotangent at pi thirds is again x over y, so that's 1 over root 3 plus the cosecant at 2 thirds, which we've already done here, is 2 over root 3 times negative cosecant at pi thirds. My sine at pi thirds is root 3 over 2, so my cosecant would be 2 over root 3. Okay, and we can multiply straight across. So I've got a negative times a negative is a positive. 2 times 2 is 4 on top. On bottom, I've got root 3 times root 3 times root 3 is 3 root 3. Plus the 2 times the negative 2 is negative 4. Over the root 3 times root 3 is 3. Okay, I am okay if you leave it at this step on your final. If you did need to simplify for something like your SAT, I would get a common denominator by multiplying this right fraction by root 3 on both sides. So now I've got 3 root 3 on both sides, and I can add straight across. 4 minus 4 root 3 over 3 root 3 would be my derivative. Okay, any questions on any of these four? Okay, so this section I've actually moved to your oral exam, so you guys will be doing that this week. Most of you during this weekend. Your unit circle integration section is similar, but it'll be in the written portion. So let's try these two really quick. If I integrate cosine, what's going to happen? Abby. So all of this is cosine. Integration is asking what would I need to derive in order to get cosine x? Sine x, press C, perfect. Okay, I don't need to write the plus C because we do have bounds. So I've got sine x from pi thirds to pi halves. I'm going to plug in my upper bound and subtract my lower bound. This is the sine at pi over 2 minus the sine at pi over 3. Okay, now you guys will have a calculator for this, since this part is on the written section. However, the sine at pi halves is 1, and the sine at pi thirds is root 3 over 2. If you are using a calculator, please make sure you're in radians whenever you're doing anything with a pi. And in degrees if you've got a degree sign. Yes, anytime that you see a pi in your problem, your calculator needs to be in radians. Okay, so sine at pi over 2, we said it was 1. Sine at pi thirds, we said it was root 3 over 2. If I subtract these, this is 2 over 2 minus root 3 over 2 to get my common denominator. Gives me 2 minus square root 3 over 2 for my final answer. Any questions on what we did here? Okay, slightly more challenging. What am I on? We just finished Abby. I think I'm back to the top. So, Nikita. Okay, I want to integrate this. If you had to pick a u substitution, so your inside part of the function, what do you think u would be? I could try that, but if I do secant tangent, if I derive secant tangent, I'm going to have a massive product rule problem. And I won't get secant cubed, so that's not it. I'm going to try something else. What else could you be? Secant cubed. If I do all of secant cubed, then when I derive this, I'd get 3 secant squared x times secant tangent. That's really close because that gave us a secant tangent. That's not actually the inside part. So I'm going to try just secant. That's the inside part of this secant cubed. What happens when I derive secant? That's if I derive cosecant. Secant tangent. Okay, so that means this part is u prime, and this part, the secant x, is u. So I'm going to rewrite this. So this was u cubed. Okay, I'm going to jump to the next person, then we'll go through this again. So let's go Eric. Eric, what happens when I integrate negative 4u cubed? Don't have any secants or tangents, I've just got a u. If I want to integrate negative 4u cubed, what will happen? Cool. So if I integrate, I'm going to add 1 to the power and divide by the new power. Okay, this is u to the 4th power over 4. My 4's can cancel, so I'm left with negative u to the 4th power. Now I can go back and resubstitute. U is secant, so this is negative secant 4th of x. And I'm going to go from pi 4ths to pi 3rds. So I have negative secant to the 4th power of pi 3rds minus negative secant to the 4th power of pi 4ths. Okay, my secant at pi 3rds, my cosine at pi 3rds is 1/2, my secant is 2 then. So this is negative 2 raised to the 4th power. Minus negative is plus. My cosine at pi 4ths is root 2 over 2, so my secant is 2 over root 2. I'm going to raise that to the 4th power. Okay, 2 divided by root 2 is the square root of 2. So I've got square root of 2 raised to the 4th power. 2 raised to the 4th power is 16. If I have square root 2 times square root 2 is 2, times square root 2 is 2 square root 2, times square root 2 is 4. So I have negative 16 plus 4 is negative 12. Okay, I'm going to double check this since we messed up last time by deriving what we had originally. So this is negative secant to the 4th power of x. If I derive it, what will I get? Niall, go for it. If I derive negative secant to the 4th power of x, what will happen? Okay, I'm gonna write this again. This is secant x to the 4th power. So what would you do? Secant x to what secant x to what power? 3rd power, okay. Then times chain rule, I heard you say it, times what should go here? Secant x tangent x with chain rule. Okay, so if we did this right, this should be our original problem. What happened when we derived our answer? So negative 4 secant x tangent x times secant cubed x is perfect. So we were able to work backwards. What we're really doing with our u substitution for integration is I'm trying to figure out what part of this was the part that we multiplied by because of chain rule. So u prime is what we had to multiply with chain rule, so that's secant x tangent x. U is the part that we had to derive in order to get our chain rule part. So u is secant x. Okay, I'm going to go back to our problem in full. Any questions on this one? Okay. I've got 45 minutes left, I think. I'm going to skip continuity because everybody's been doing pretty well on continuity. I'm going to look at the curve sketching stuff though. So this first part says I have a vertical asymptote at x equals -3. A vertical asymptote is a line that our function never crosses. It's a little bit bigger. A line that our function never crosses. At x equals -3. I've got horizontal asymptotes at y equals 1 and y equals 2. So at y equals 1 and y equals 2, that means the ends of the graph should approach these two horizontal lines. I am concave up from -infinity until -3. So I am concave up on this side. I'm concave down on -3 to infinity. I'm concave down on the other side. I have an x-intercept only at x equals 2. Okay, so I'm going to do something like this. I'm concave down from -3 until infinity. They've got an intercept around 2-ish. I am concave up on -infinity to -3. And we've got both of our horizontal asymptotes. We're approaching 2 and 1 on both sides. Okay, any questions on our curve sketching? Okay. And some limits. I forget who we're on, so I'm going to start over. I'm going to go down the list this time. So starting with Abby. I've got a polynomial on the bottom and an exponential on top. Which will grow faster, the top or the bottom? Okay, one on the bottom is a polynomial. Okay, for limits at infinity, oops, make it smaller again. Okay, factorials grow faster than exponentials. Grow faster than polynomials. Grow faster than logarithms. Grow faster than sine or cosine. Grow faster than constants. So we said feed elephants peanuts, love someone cool. Okay, so this is an exponential. This will grow faster on top. So if I plug in infinity, then this will approach infinity. What is -infinity minus 4? Okay, -infinity. I'm going to count down forever and then subtract 4. I'll still have an infinitely small number. Okay, next one, Andrew. Okay, I'm approaching infinity. Are my powers the same or bigger on top or bigger on bottom? Powers are the same. Okay, so if my powers are the same, I should approach the fraction of my coefficients. What's the fraction of my coefficients? Root 3, perfect. So if I do the square root, this will be square root 3x, and then square root 1x. So this will approach square root 3. How did we get there? So for your limits at infinity, if you are faster on top and slower on bottom, then you will approach infinity or negative infinity, depending on the sign. If you take your limit as x approaches infinity and you've got the same growth rate, then you'll approach the fraction of the coefficients, which is what happened here. X squared, that's the same value for the largest power on top and bottom. So that means I'm going to approach the fraction of my coefficients, which for us is square root 3 over square root 1 is square root 3. Okay, if you take your limit at infinity and you have a slower rate on top, then you will approach 0. Problem for this one, Jin's next. I'm approaching, oops, I'm going to change this a little bit. I'm approaching positive 2 from the left. If I'm approaching positive 2 from the left, will I need to plug into the top one or the bottom one? Top one, okay. So I'm going to plug in positive 2 into this equation. So that'll give me 2 over 2 minus 2 is 1 minus 2 is negative 1. I'm a little bit smaller than 2. Okay, if I didn't change that, so if I wanted to plug in negative 2 from the left, negative 2 is still less than 2, so I'd still plug into the top one. So this would be negative 2 over 2 minus 2 is negative 1 minus 2 is negative 3. Okay, next one, I've got an absolute value. Next on my list is Eric. Eric, what's going to happen here? Okay, so I'm going to put in negative 3 plus a little bit. Negative 3 plus a little bit, minus 3. Okay, so this is like negative 2.9999999. If I have a negative times a negative, that will become positive. So this will become positive 2.99999 forever, minus 3. Will my answer be positive or negative? Okay, so this 2.99 minus 3 is negative. So I'm going to have a negative number, 0 minus a little bit, inside this absolute value. Okay, this is the same thing that was here. So this would also be a negative number, but I don't have the absolute value, so this bottom one will stay negative. This top one has an absolute value sign, so it will become positive. Okay, so I've got the same number divided by the same number, but one is positive and one is negative. So what should my answer be? Negative 1, perfect. Okay, next up is believe that's Andrew. Andrew, this is a floor function, so I'm always going to round down to the nearest integer. If I plug in -2 minus a little bit, what's going to happen? What is -2 minus a little bit? So actually the other way. -2 plus a little bit would be -1.9999. So this is negative, right. We've got infinitely many zeros in there. Okay, so what is -2 times -2.01? Okay, so I've got 4.01 minus 2. What is 4.01 minus 2? Okay, if I round down to the nearest integer, what will I get? 2, perfect. Okay, any questions on this one for our floor function? Okay. Next up is Kyle. Okay, so Kyle, I'm going to plug in -2 plus a little bit. If I do, I need to be a little bit more specific. -2 plus a little bit is like what? Other way. Adding to a negative number. There we go. Okay, so this is the same thing as 3e to the 1 over, if I have -1.99999 plus 2, what will I end up with? 0 plus a little bit, okay. Over e to the 1 over 0 plus a little bit, plus 1. Okay, what is 1 over 0 plus a little bit? I'm dividing by a super small number. Will my number get larger or smaller? Okay, so I should actually get larger. 1 divided by 1 is 1. 1 divided by 2 is 0.5. Okay, so if I divide by smaller and smaller numbers, so instead of dividing by 2, I'm dividing by 1, I actually get larger. 1 divided by 0.5 is 2. If you had one sheet of paper and you divided it into infinitely small parts, you would end up with a lot of sheets of paper. Okay, so this is 3e to the infinity over e to the infinity plus 1. Okay, so I've got 3e to the infinity over e to the infinity plus 1. Is my power growing bigger on top, bigger on bottom, or the same? Perfect. Yep, our growth rate of the largest growth term is the same on top and bottom. So this one should approach 3. Okay. Oh, I've got this -2 on the outside here, actually, which I forgot about. So I need that too. -2, -2, -2. Okay, so this would be 3 minus 2 is 1. Okay, any questions on what we did here? Okay. Down here, I've got sine at 0 over 0 if I plug this in. Okay, so this is L'Hospital's rule. Because if I plug this in, the sine at 0 is 0. If I plug it into the bottom, I've also got 0. So I've got 0 over 0. Does anyone remember L'Hospital's rule? Yes. So I'm going to derive the numerator and I'm going to derive the denominator separately. Okay, so that means this limit is equal to the limit as h approaches 0 of, what's the derivative of sine? Cosine. What's the derivative of h? 1. Okay, if I plug in 0 right now, what's the cosine at 0? 1. Okay, so my answer is 1. L'Hospital's rule says if you have a limit and your limit ends up being 0 over 0 or plus or minus infinity over infinity, then we can derive the top and the bottom separately and take the limit again, and we'll get our answer. This is the written part. So you will have notes for this part. Yes. I'm looking at, so I'm looking at the oral exam being about the same length, yes. Yes. This oral practice that I sent last time, all I did for the other oral exams was I just changed the form number. So you're going to see the exact same format for your oral exam when you go into it. So same thing, different numbers. So if you're good on the practice, you should be fine on the real thing. Okay. So for this one, I believe we are back to, we just had Niall, so Nikita. There are two ways to solve this. What would you do? Okay, we could factor the denominator. Nikita, what does this factor into? H squared plus 5h plus 6. Okay, so we can cancel then our h plus 3. And that'll leave us with -1 over h plus 2. And now I'm ready to plug in -3. So what should our final answer be? Okay, so this is -1 over -1, which is 1. Perfect. Okay, the other way we could have done that is L'Hospital's rule would apply here too, because if you plug in -3, I get 0 over 0. So you could derive top and bottom and you get the same answer. Okay, last one, formal definition of a derivative. I'm back to the top, so Abby. Okay, again, there's two ways we can solve this. Which way do you want to use? Okay, unmute you really quick. Okay, never mind, I can't. Okay, I've lost Abby, so I'm going to skip over to Andrew. Andrew, which way would you want to use to solve this? I'm gonna let you. Okay, I'm gonna let you do that. However, it is very possible that I could give you something like this instead. So go to the 13th power. So even though that will work for this one, that's probably not going to work for all of these. If I did want to expand this right now, this would be 1/3 cubed plus 1/3 squared h plus 1/3 h squared plus h cubed minus 1/3 cubed over h. So, Andrew, I'm going to let you keep going. What happens next? Okay. Okay, so that leaves me with limit as h approaches 0 of 1/3 squared plus 1/3 h plus h squared. Okay, then what? Oh, hold on. I actually haven't factored this correctly, have I? I need a 2 here for these two terms. 2. Okay, but you're right. Then I'm gonna get limit as h approaches 0 of 2 or 3? 3, my bad. 3 a squared b plus 3ab squared plus, yeah. Okay, so I've got 3 times 1/3 squared is 3/9 is 1/3. Okay, I don't actually want you guys to solve it this way, partly because that means you're going to have to expand all of these binomials, which we can do, but if I made this something like 13 instead of 3, then you guys are going to be here the entire time for the test on this one problem. So I've got 2 other ways that we could solve this. So I'm going to flash here really quick. Okay, the first is we could use the formal definition of a derivative, and the second is a hospital's rule will actually shortcut this as well. So I'm going to show you a hospital's rule first, because that's probably the easiest now that we've got the shortcut. If you plug in 0 right now, you'll have 1/3 cubed minus 1/3 cubed is 0 on top, and on bottom you've got 0. So that tells us L hospital's rule can apply. So if I derive the top and derive the bottom separately, we should get our answer. So this would be, if I derive the top, I'll get 1/3 plus h. I'm going to multiply by 3 and decrease the power by 1, and then multiply by the inside. The derivative of the inside is 1. Okay, divided by 1. Then we'll take the limit as h approaches 0. I can plug in 0 and I'll get 3 times 1/3 squared is the same thing that we just got. 3 over 9 is 1/3. So L'Hospital's rule can apply, and that can be really fast. The other way we can do this is because this is in the form of our formal definition of a derivative. So what I mean by that is our definition of a derivative, f prime x, is the limit as h approaches 0 of f of x plus h minus f of x over h, right? Which is the same thing here. If my f of x, a function of x, is x cubed, I'm taking this function and I'm cubing it. So my derivative then should be 3x squared, and my x value right now is 1/3. So that's 3 times 1/3 squared is 3 over 9 is 1/3. Okay, either one of those ways is going to be faster than trying to expand this binomial. And have a lot less room for mistakes. Any questions on this one? Formal definition of a derivative. Okay, I'm going to try another really quick. So, Andrew, I'm going to go back to you one more time. I want the limit as h approaches 0 of 1/2 plus h to the 103rd power minus 1/2 to the 103rd over h. Okay, Andrew, how can you solve this? Okay, L'Hospital's rule. Okay, the reason that works is because when you plug in 0 right now, you've got 1/2 to the 103rd minus 1/2 to the 103rd is 0 over 0. In order to use L'Hospital's rule, you must get 0 over 0, or infinity over infinity, or negative infinity over infinity. Okay, if you get any of those three, then we can use L'Hospital's rule. Okay, sorry, Andrew, keep going. Okay, to what power though? Okay, then I can take the limit as h approaches 0 and I'll get my answer. So what's our answer? I'll get 103 times 1/2 raised to the 102 power. And I'm okay if you leave it like that. No, you don't have to simplify for anything on the test. Okay, last one. Next would be Jin. Jin, what would I do here? Okay, so you factored. Okay, there's nothing that can cancel. Okay, so my next step, just plug -1 in and we'll see what happens. What happens if you plug in -1? Okay, -2 over, I've got -1 and -3. -2 over 3, perfect. Okay, any questions on limits? All right. Let's do some more curve sketching stuff. Actually, okay, we've got about 10 minutes left. I'm gonna give us an option. We've got curve sketching, related rates, optimization, integration, projectile motion, sign modeling, nonlinear regression, which we went over last time for the oral test, or integration as area or volume. Does anyone have a preference? So something you want to go over? Okay, I'm going to try to get curve sketching and try to do the related rate one then. So for this curve sketching graph, the first thing you need to do is check to see what graph you were given. And you're going to match to another type of graph on the right. So in this case, I'm matching the original graph to its derivative. So that means these graphs on the right represent the slope of this graph. Okay. So let's go Eric next. From -infinity until -4, my original graph is decreasing. So that means this graph that we're matching it to on the right side should be negative. Which graphs can we eliminate? Okay, A and C both do not start negative, so it can't be A or C. Okay, I do have a positive slope here from 0 to 4. So my y value should be positive, and a positive slope from 4 to 8. So my y value should be positive after 0. Both of these have negative slopes before 0 and positive slopes after 0. Which one do you think is correct? B or D? Okay, boy. My slope is undefined at -4 because I've got a vertical asymptote, and at +4, which is true for B. Also, my slope is changing. It's becoming more negative. And from -8 to -4. So I have a super negative slope around -4, which is true for B. I'm at -infinity, but not true for D. Okay, one more, Kyle. This graph is the original again, and I'm once again matching to a slope. How would you start? Tell me why. Okay, you said increasing after 2. Right now, I'm increasing after 4. And I'm increasing from -infinity to 0. Okay, so let's try with that. These graphs on the right-hand side represent the slope. So that means I should have a positive slope from negative infinity until 0. Is there any graph here where my y value is not positive from negative infinity to 0? Okay, C is positive from negative infinity to 0. Okay, B is also positive from negative infinity to 0. A is positive from negative infinity to 0. D is not. D starts negative, so I'm going to get rid of D. Okay, then from 0 until 2, my slope is down. So that means my y value for the slope should be negative. Okay, from 0 to 2, my slope needs to be negative. Which one can I eliminate? C, right? So my y value is positive here, so that would mean my slope is positive for the original, which it's not. Okay, so that leaves me with A and B. My slope is undefined at 2. So which one can I eliminate? Okay, B is just a straight line, which their slope is defined everywhere, so this one must be A. Okay, working backwards, now this graph is the slope, and this graph is the original. Okay, so my slope is negative from negative infinity to 4. To negative 4, sorry. So I should be going down from negative infinity to negative 4. That's true for A. It's true for B, but after negative 4 I start going up, and that's not true for B. Going down until negative 4. This is going up until negative 4, so that can't be true. Going down until negative 4. Okay, that's true, but it keeps going down. Where R1 starts going up, so that's not okay. So this one must be A. Okay. Why is it A and not C? So this graph on the left is our slope this time. So if this graph's y value is positive, then the slope of this graph on the right should be positive, right? This one cannot be C because our slopes graph started negative, where C started going up. From negative infinity until negative 4, our f prime is negative. So that means the slope of f of x should be negative, which means we would be going down from negative infinity until negative 4. But for C, our graph goes up from negative infinity until negative 4, so this one cannot be C. Okay. I'm going to skip, and we'll look at a related rates problem. Okay, so I've got Francis, who's trying to record this firework. The firework is launched from rest. It accelerates at 2 meters per second squared. The firework explodes once it reaches a velocity of 20 meters per second. Her camera is 240 meters away from the firework. I want to know how far will the firework be from the camera when it explodes? And how fast will the distance between the camera and the firework be changing at the instant it explodes? So I want to know what is D at the moment the firework explodes, and what is D prime at the moment the firework explodes. Okay, so first, I was told the firework is accelerating at a rate of 2 meters per second squared. So if that's true, then if I integrate 2, I'll get the velocity, so that's 2t plus the initial velocity, which is 0. If I integrate velocity, I'll get the height. So height at any time, velocity at any time. acceleration at any time. Okay, her height will be 2t squared over 2, or t squared plus 0t plus, and she's starting at the ground, right? Yeah, so she's starting launching from rest at the ground, so that's also plus 0. Okay, any questions on our setup for the first set of problems? How to get the height, velocity, acceleration. Okay, the firework will explode when the velocity is 20 meters per second. So if Vt is 20, that'll give us the time when the firework explodes. Her velocity at any time is 2t, so that's 2t equals 20. The firework will explode after 10 seconds. Okay, then I'm going to get the height. So what is the height that the firework will explode at? So that'll be my y value, which is ht. Her height at 10 seconds will be 10 squared, or 100 meters. Height is t squared, t is 10. So y is 100 meters when the firework explodes. Her camera is 240 meters away from the firework, 240 meters away. If the firework is shooting straight up, then that distance still will not change. The horizontal distance won't change. D will change though, according to Pythagorean's theorem. D squared equals x squared plus y squared. Right now, I know what x is and I know what y is, so I can plug that in and solve for d. So that tells me d squared is 240 squared plus 100 squared. Or d is the square root of 240 squared plus 100 squared. Okay, square root of 240 squared plus 100 squared is 260. So the firework will be 260 meters away when it explodes. And if I want to know how fast the firework is traveling, then I can derive this equation to figure out how fast d is changing. So that would look like this. 2d dt over 2d dt over dt. If I derive d squared in terms of time, 2 times d times chain rule, dd over dt. If I derive x in terms of time, x squared, this will be 2x times dx over dt is how fast x is changing, plus 2y times dy over dt. Okay, then I'm going to plug in everything we know. I know dx over dt is 0 because the horizontal distance is not changing. I know dy over dt was her velocity, which is 20, was given. So this will be 2 times d, which is 260, times dd over dt is what we're trying to solve for. 2 times 240 times 0, because that distance is not changing, plus 2 times 100 times 20. Gives me 520 dd over dt is equal to okay, so I've got this 4,000 over 520 meters per second is how fast the distance from her camera to the firework is changing. Okay, so I've got 3:45-ish right now, so I'm gonna stop there. If there's any questions, I can answer those before you guys leave. If not, I'm gonna repost all of the previous year's finals, which has the solutions to them in there as well as a study guide. If you guys have more questions, please let me know on WeChat. And then hopefully I will see you on Monday or Tuesday, and I'll be contacting you for the oral exams. Thank you very much. Goodbye.